So welcome back, Level 1 physicists and earth scientists, continuing on with 1.1, the linear relationship internal. And today we're looking at how we're going to record our results when we do our experiment. Okay, so the results are very important, okay, and basically we collect the results, we analyze our results to see if our prediction that we made right at the start of the experiment is correct, okay. And you have to present your results to the person reading the report to make sure that your results are accurate and they make sense, okay? And you also need to explain how you improved the accuracy of your results as well when you're writing your report. So in terms of collecting results, you need to choose a sensible range for the independent variable. So what's a range? Well, it's basically the smallest value that you take and also the biggest value that you take. So you need to consider what would be sensible in terms of a value for your independent variable and what would be sensible for the value for your biggest value for your independent variable. Okay, so that's what I would recommend, that before you begin your experiment proper, that you try a small experiment to see which values are too small and which values for your independent variable are too big to collect, okay, for various reasons. For example, reaction time might be an issue, or the equipment that you're using, okay? And you have to explain why you chose that particular range of values for your independent variable in your report. So one way to improve accuracy of your dependent variable is to take an average, okay? So to do that, you basically have an X number of values for your dependent variable, okay? Probably a minimum of 3, a maximum of 5 values for each independent variable value. And then you add all those dependent variable values up for that one independent value reading. And then you divide the value by that number of values that you've taken, be it 3, 4, or 5. Okay, and this is an average value which you will use later when you're starting to analyze your results and start plotting graphs. Okay, and you also need to record these average values in your table and also explain how you calculated that average and why you're using it, which of course is to improve the accuracy and reducing random error. Okay, so in terms of that result table, you need to have enough columns to handle all the data that you're going to be creating. Okay, an appropriate unit for each of the variables. Okay, and you need to take multiple readings for the reasons outlined previously for both the independent and dependent variables. And then you have to average the dependent variable, and what you also have to do is remove any anomalous results. Okay, you mention them, but you say you've removed them because they do not reflect the data. Okay, so you also need to show, as I said in the previous slide, an example of how you've taken the average when you've done the calculations. Okay, so there's an example of a table. Obviously, you'll have your own independent variable and your own unit for that independent variable, and your own dependent variable and your own unit for that dependent variable, depending on what your experiment actually is and what your prediction is based around. Okay, so this is just a general guide of how you would construct a results table. Okay, so next lesson, we're going to look at, once you've collected the results, how do you use that to analyze the data.